Hi, we are discussing the structural engineering 2, design of steel structures subject. So in that, already we have discussed the lecture 1, that is introduction to steel structures. So in introduction to steel structures, we have discussed the materials. So what is steel? Steel is nothing but the made up of iron and carbon. And we have discussed the advantages and disadvantages of steels and the difference between RCC structures and steel structures and the mechanical properties of steel, physical properties of steel means the Young's modulus of steel 2 into 10 power 5 Newton per mm square and modulus of rigidity CR modulus value 0.769 into 10 power 5 Newton per mm square and Poisson ratio 0.3 in the elastic range, 0.5 in the plastic range. And density of steel, unit height of steel 7850 kg per meter cube. And thermal coefficient of thermal expansion 12 into 10 power minus 6 per degree Celsius. Now we have discussed under mechanical property, ductility, toughness, hardness, yield strength, ultimate strength, and all we have discussed on the applications of steel, chimneys, silos, steel bridges, multi-story building. So those things and all we have discussed on merits and demerits. Everything we have discussed in the introduction topic. And today we are going to discuss various types of structural steel. So we already discussed the structural steels are manufactured in the factory in some standard sizes with the properties, different properties, and it will be used for the construction of the steel, right? Steel structures. So in order to use in the construction work, steel should be available in certain forms, which are known as the steel sections. Another name of steel section is rolled steel section. It is rolled in a steel mill. So it is called rolled steel section in the commercial forms or the market forms. So many steel sections are readily available in the market and are in the frequent demand. Such steel sections are known as the regular steel sections. And some steel sections are not in use commonly, but such sections can be made out in steel mills. In some special places, the steel sections are used. Therefore, that is called the special sections. So structural steels are rolled into various shapes and sizes. So in steel structure, sections having large modulus of sections are generally preferred. So the modulus of section. So you know the modulus of section Z is equal to I by Y. Z directly proportional to the moment of inertia. So fractional rigidity EI Young's modulus into moment of inertia. So moment of inertia is increased. Section modulus. Section modulus is nothing but it's the strength property. Okay. So having large models of sections are usually preferred in the steel structures. And steel sections are named according to their cross-sectional shapes based on the shapes of the steel section, which can be named. And steel in which carbon content is up to 2% is known as the carbon steel. And steel in which carbon content is more than 2% is known as the cast iron. Now we will see the types of structural steel. These are all the images of different forms of structural steel section, rolled steel sections. So structural steel sections also called as rolled steel sections. It is I section. Okay, wide flange I section. The width of the flange is more. That is called wide flange I section. And I section or B, rolled steel. Channel section, angle section, T section, circular section, hollow circular section, hollow square section. This is bar, rectangular bar, circular bar on the plates. Okay, you can see this is the 3D view, so TB. Okay, you can see this is the angle section. Okay, it's like a L shape, L angle. This is hollow square section. This is wide flange section. This is I section. And this one is seated channel section. Okay. So types of rolled steel section or types of structural steel sections are rolled steel I section or rolled steel beam section. Second one is rolled steel channel section. Third one, rolled steel angle section, rolled steel T section, rolled steel bars, rolled steel tubes, rolled steel plates, rolled steel sheets and strips, rolled steel flats. Right. So now we can see one by one the rolled steel I or beam section. Okay, here you can see this is the I section. Okay, so here this portion is called flange portion, and this portion is called web portion. So the I section here, this is the top flange, and this is the bottom flange, and between web. Okay, so this is the depth of the I section, and this is the width of the I section, and this is the thickness of the web, and this is the thickness of the flange. So the thickness of the flange denoted as T suffix F, thickness of the web denoted as T suffix W. Okay, so breadth of the flange or width of the flange denoted as B suffix F, and this is the depth of the I section. So I and T sections are named based on their shapes. I section is usually referred to as rolled steel joist or the beam with less cross section and higher moment of inertia possible. So in the case of I section, with less cross section, we will have the higher moment of inertia. So I already said moment of inertia is more, section modulus will also more. Z is equal to I by Y, directly proportional. So the strength of the section will be good. So RJ, rolled steel joists, are used for the floor beams, lintels, columns, etc. We can use this type of I section. And the economical use of material is derived by concentrating the material on the flange where the bending stresses are maximum. So in strength of material also we studied bending stress sigma by M by I is equal to sigma by Y is equal to E by R. So M by I is equal to sigma by Y. So right. So M is equal to sigma by Y into I. So when the depth is increased, so usually the bending stress of the neutral axis will be 0, right? So Y is nothing but this D by 2 is Y. So when the depth is increased, the bending stress will be increased. Okay, when the depth is increased, the bending stress will be increased. Therefore, at the neutral axis, the bending stress is at 0. On the extreme top fiber, the maximum compressive bending stress you will get, and extreme bottom fiber, you will find the maximum tensile stress, maximum bending tensile stress. Therefore, in the top and bottom, it is subjected to more bending stress. So here we need to provide more material on the center. It will not require that much material to resist the load. Therefore, this I section is okay, very much good section. Okay, so less cross section the higher moment of inertia will be possible. Why? Because I is equal to moment of inertia. I is equal to BdQ by 12. So B dq. dq means d power 3. So here depth is high compared to the breadth B. So B is 1 times, depth is 3 times d cube. So depth is high. Therefore, the moment of inertia value I directly proportional to B dq. D I direction on D. Therefore, D value is high means. So you will get more moment of inertia with the less cross section. Therefore, the I section is mostly preferred. Classification of I sections are Indian Standard Junior Beam, that is ISJB, Indian Standard Lightweight Beam, ISLB, Indian Standard Medium Weight Beam, ISMB, Indian Standard Wide Flange Beam, ISWB, Indian Standard Heavy Beam, ISHB. So Indian Standard Junior Beam means it will have very less depth, and lightweight beam means lesser weight, medium weight beam means medium weight, and wide flange beam means, okay, so the width of the flange will be more, okay, when compared to these above beams. And ISHB means heavyweight beams. The weight is much more than other beams. The maximum depth of the I section is 600 mm. So this is the depth of the I section. Generally, when they manufacture, the maximum depth is restricted to 600 mm. This type of rolled steel I section. So each beam section is designated by the series to which it belongs, followed by the depth and weight per meter run. For example, ISMB 500 at 0.852 kN per meter means, so medium weight beam section of depth is 500 mm with a self weight of 0.852 kN per meter. So first 500 depth, then second this 0.852 is self weight of the beam. Okay, in some cases of wide flange beams, that is ISWB, and heavy beams ISHB, more than one section is available for the same depth. For example, ISWB 600 or ISHB 600. For the same depth, there are two sections also available. The difference is the weight. The weight may be differ, but depth is same. So edge beams use ISWB where torsional and lateral loads is predominant. So generally in the frame structure, end beams, edges we are providing beam, no? So there generally the lateral force and because of the eccentric load, the torsional load and all heavy. So in that situation, when we are providing the wide flange beam, it will be more useful, more suitable. So for example, ISWB 600 or 1.423 kN per meter, ISW 600, same depth, but the weight is different. ISW 450, same depth, 450 mm depth, but weight is different. So most structural steel shapes such as I-beam have high second moment of area, which means they are very stiff in respect to their cross-sectional area and thus can support a high load without excessive sagging. So as I said earlier, so without bending, without sagging, it can resist more load. I section is the second moment of area is more in the case of I section. On rolled steel channel sections, coming to rolled steel channel section, it's like a C type. Okay, it has two equal flanges. There you can see this is one flange and this is also one flange, equal flanges, two equal flanges and a web. A channel section is designated by height of the web and the width of the flange, and they are available in different forms, sizes. They are used in steel framed structures, girders and steel bridges, and all. This type of channel section is used. And this type of channel section mainly used in the purlin, the roof truss. Okay, in inclined purlin beam is there because of the eccentricity load. It can be balanced by the twisting force. So as already we studied in the strength of material, shear center. So suppose this is a CG. So when the load is acting at a point somewhere else outer side, this can be equalize the torsional effect of this beam due to load acting in the beam. So that point is shear center point, right? So in such type of inclined beam, the roof trusses and all where we provide the purlin and all, when we use this type of channel section, so because of the shear center action, it can be a balance in the torsional load, torsional moment as well. So this channel section is preferred girders, steel bridges, and the purlin, the roof truss. So these sections are also classified into 4 series: Indian Standard Junior Channel ISJC, Indian Standard Lightweight Channel ISLC, Indian Standard Medium Channel ISMC, Indian Standard Special Channel ISSC. So here also ISLC 350 means it is denoted as the depth, then at 0.35 this is the weight. Okay, generally a channel section has only one axis of symmetry, x direction. Due to this, it is subject to twisting or torsion along with bending when used as a beam, right? As we said earlier, channel section torsion may be possible. So when we provide in the purlin inclined roof, it will be more. And rolled steel angle sections. Rolled steel angle sections are 3 types: Indian standard equal angles, Indian standard unequal angles, Indian standard bulb angles. So here the image, this is a, you can see so equal angle means both leg are equal dimensions, unequal means different dimension, and bulb angle is like this. And rolled steel angle section, since the equal angle section and the unequal angle sections are designated by the same series, that is ISA. Here equal angle section also we designated as ISA, unequal also we designated as ISA. But in equal angle section, it is equal leg. Both leg are equal, 60 mm by 60 mm, thickness 6 mm. And unequal angle section, both legs are different, 100 mm by 75 mm by 6 mm. Indicate the depth is 100 mm with this 75 mm and the thickness is 6 mm. So bulb angle is the unequal leg, and then only its depth is mentioned along with the series ISBA 300, means it's the depth angle 300. And rolled steel T sections. So this is the width of the flange and thickness of the flange and depth of the weld. Okay. So 5 series of T sections are available: Indian Standard Normal TISMT, Indian Standard Heavy Flange TISHT, Indian Standard Special Leg TISSLT, and Indian Standard Light TISLT, Indian Standard Junior TISJT. And rolled steel bars. So there are 2 series in rolled steel bars. So Indian Standard Round bars, ISRO, Indian Standard Square bars, ISSQ. So rolled steel bars are designated by ISRO followed by the diameter in case of the round bars, and ISSQ followed by side width in case of square bars. For example, ISRO 16 means 16 mm diameter bar, ISSQ 20 means 20 mm width. Any one dimension. Rolled steel tubes. So these sections are designated by their nominal bore sizes. And in each size, there are 3 classes: light, medium, and heavy, based on the thickness. If thickness is more, the section will have more weight, heavy. So because of this, the sectional properties are also different. For example, a 40 mm tube may have 3 different thickness. 40 mm tube with a different thickness, 2.9 mm, 3.25 mm, and 4.05 mm like this. So rolled steel plates. Rolled steel plates of the following thickness are available. The plate thickness is a different thickness, and width also it has different width you can get. And rolled steel sheets and strips. So this is the rolled steel sheets. So ISST. These sections are available in width and thickness. Okay, so this is a width and thickness, ISST 250 by 2.5. So 250 mm width, 2.5 mm thickness. Okay, Indian rolled steel sheets or strips. And rolled steel flats. Flats are different from the strips in the sense that the thickness of the flat is 5 mm onwards, but the width is limited. So width of the flat is very less generally. So with this, these are the width and these are the thickness of the flat section. So they are designated by width followed by the letter ISF, Indian Standard Flat, and thickness suppose 80 ISF 10 represent 80 mm wide width and 10 mm thickness. So generally flats are used in grill works and railway. It is more costly than the strips or strips. Okay. So these are all the types of rolled steel sections which are available in the market, and the properties, everything will be found in the IS handbook or the steel table. So when you refer the steel table or IS handbooks, you can get the properties of the rolled steel sections where we can find the all the values like what is the suppose ISMB 500 means what is the separate depth, thickness of the flange, width of the flange, thickness of the wave. Okay, so here this CXX value. Okay, everything can, all the properties, radius of gyrations, everything, all the properties can find out from the steel table for the different cross section, I section, T section, angle section, channel section, for all the sections, for all the depth, so I can find out the properties. Okay, so these are the various types of structural steel: I section, channel section, angle section, T section, bars, tubes, plates, seats, and strips, flats. Okay, so thank you all. Thank you for listening.